Okay, good morning, guys. So our last type of word problem that we're going to be talking about is still interest, but instead of it being compound interest, it is continuous interest. So the difference between the two is that continuous interest, if you remember on Monday, whenever we were talking about interest compounded, we said quarterly, which means it happens 4 times a year. Compounded annually means it happens 1 time a year. Compounded monthly means it happens 12 times a year. Compounded continuously means that it's constantly gaining interest every second, every instant, okay? So the definition that I'm going to ask you to write down, continuously compounded interest, it is the interest that is computed or calculated, interest that is computed and added to the balance of an account, every instant. It is always gaining interest. There's no stopping point, okay? So because how often it's gaining interest, you're typically not going to see this in a bank, okay? So in order for you to use this formula that I'm going to tell you in a second, the word problem it absolutely must say the word continuously in here. That's going to be like your number one thing, is to look for this word in order to use this formula. If you do not see the word continuously, you are not using this formula. You're going to use one of the other ones that we had done earlier in this distance learning process. Okay, so if it says continuously, use this formula. I know some of you have already taken Algebra 2, so this probably will sound familiar. The formula is A equals P times E raised to the RT, APERT. Okay, we call it APERT a lot of times just to, for short, to remember it. So the difference between this formula and the other ones is that your base is not, it is a number, but your base is one of those famous irrational numbers like pi, right? The base here is E. The base here is E. This is not a variable. You're not plugging anything in for E. If you remember, E is on your calculator. It is, if you press second and then the division sign on a graphing calculator, you get E, which is, it's 2.71828, blah, 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 blah. Okay, so you're not plugging anything in for E. So all of your variables really do stay the same. A, as always, is your end amount. P is your starting amount. R is the rate expressed as a decimal, so you have to move the decimal over 2 times if it's a percentage, like always. And T is the time. Okay? And again, you're not plugging anything in for E. E is on your calculator. Okay? All right. So your first example down here says a total of $20,000 is invested at a fixed annual interest rate of, interest rate of 4.2%. If the interest is compounded continuously, so right away you can stop. You see that word, so you can write down the formula that you're going to use, APERT. The question is algebraically determine what the balance would be after 12 years. What the balance would be, that means that you are solving for A. You're solving for A, so you have to plug something in for P, for R, and for T. Again, you are not ever plugging anything in for E. E is E. It's a number. It's just represented as the variable E. P is how much you're starting with. So in this case, we started with $20,000. So we have $20,000. R is the rate. So it's 4.2%. You move that decimal 2 times to the left. That would be 0.042. And T, we want the balance after 12 years. So T is going to be 12. So if I plug this into the formula, A equals P is 20,000. E raised to the R, 0.042, times T times 12. So both R and T are part of your exponent, just like how they were for compound interest. Just like how n and t was for compound interest. Again, whenever you're solving these, you have to think, where is your variable? If the variable is up in the exponent, you need to use logarithms. If not, then you don't. So in this case, a, the variable, is by itself on one side, so you just have to plug this side into the calculator, and we are rounding to the nearest cent. So when you plug this in, again, remember, to get e, you press second and then division, on a graphing calculator at least. And round it to the nearest cent, your $20,000 will turn into $33,106.59. Okay? And again, that's a big jump because continuous interest, right, continuously compounded interest is always gaining interest. Every instant it gains interest. And second example, number 2. Gordon invests $3,000 into a savings account that earns an interest rate of 3.2%, compounded continuously. So again, you see the word continuously, and you can write down your formula, APERT. The question says, algebraically determine how many years, round to the nearest tenth, it would take for his account to reach $8,500. So we are looking for how many years. That means that we are solving for t, which means you have to plug something in for A, something in for P, and something in for R. Again, never plugging anything in for E. So let's start from the beginning again. Gordon invests $3,000. So he starts off, the starting amount is $3,000. Earns an interest rate of 3.25%. You move that decimal over 2 times. That goes in for R. That would be 0.0325. Compounded continuously. Determine how many years, round to the nearest tenth of a year, it would take for the account balance to reach, so we want the ending amount to be $8,500. Okay, so now we plug everything in. 8,500 equals 3,000. E raised to the R, 0.0325, T. Okay, so now for this example, you see that your variable, t, is up in an exponent, so you're going to have to use logarithms for this. Now, because your base is an e, you're more inclined to use a natural log. I'll show you how to do that, though. First step stays the same, 3,000. That cancels over here. You do 8,500 divided by 3,000, and that gives you 2.83 repeating. Remember, 5 decimals equals e to the 0.0325t. So now, because the base is an e, instead of taking the log of both sides, which you still can do, which is a little bit more work, instead of taking the log of both sides, you are going to take the natural log, or the ln, of both sides. Equals, again, the variable comes out front, just like how we've been doing all week. So you have equals 0.0325t times the ln of e. Now, we talked about this the very first at-home lesson that we did, that review thing that we did. The ln of e is 1. So if you want to go ahead and divide both sides by the ln of e, you can, but essentially you're dividing by 1, and when you divide by 1, you get the same thing. The ln of e is 1. It cancels itself out. So you don't even, this line right here that I just wrote, you don't even have to write that. From that first step of taking the logs of both sides, from there all you have to do is divide by 0.0325. Okay, so that cancels. I get t equals, we're rounding to the nearest tenth of a year. It ends up being 32.04, which rounds to be 32.0 years. Now, if you don't like that, if you want to stick to taking the log of both sides, it's the same rules. So you would do the log 2.83333 divided by the log of E. If you're going to do logs, you have to do the division, okay? Either way, though, you still end up with the same answer that I just got, which would be 32.0 years, all right? All right, make sure you upload your notes onto Google Classroom, and then tomorrow you're going to have, I think there's 4 questions for homework, all right? Have a good day, guys.